Hello guys, in this video we shall solve the problem on LeetCode, find duplicate subtrees. So the given question is, given root of a binary tree, return all the duplicate subtrees. For each kind of duplicate subtree, you only need to return the root node of one of them. Two trees are duplicate if they have same structure with same node values. So they have defined what is duplicate subtree here. Duplicate here. We shall explain this one example. Let's take an example one. So that comes with the two children here, two and then three. Again, for three, you consider it as two. So if you observe from the root node, this two and two are repeated. So that means it's a duplicate tree where two is the root node. Two is the only node that itself is a root node. So in the given question, you have to find this duplicate tree. And for each kind of duplicate subtrees, you only need to return root node of one of them. So if there are two duplicate subtrees, you only need to return the root node. Here 2 is the only node in the subtree. So you return 2. Only once is fine. You need not to return it twice. Return it twice. So let's extend this example further. 1, 2 and 3 and here 4 and here 2 and 4. So if you observe here, again 4 and 4 are repeated twice. So 4 is the root node of that subtree only. So 4 is a duplicate tree. Next, if you consider 2 comma 4, 2 to 4, yeah, even this is a duplicate subtrees. So in this case the root node is 2. You have to return 2. You need not to return 2 comma 2 twice. Only once if you return, that is fine. You need not to return root node of both the trees twice. You need to return only once, one of them. You need not to return the both children as well. Only the root node is sufficient. This is not required. Only the root node is sufficient. So in this example we have seen two subtrees. I'll give one more extended example. So this contains 2 and 4, 1, 3, 2, 4, and this contains 6, and again this contains 6. So if you observe here, and this contains 4. So if you observe here, 4, 4, 4. 4 is the one duplicate subtree. Next comes in 2, 4, 6, 2, 4, 6, the entire thing. It's a duplicate subtree, but 2 is the root node. For this root node, children are 4, 6. For this root node, children is a 4, 6. So again you find the duplicate subtrees. Now we shall see the example which they have given, and we will see how logically we have to solve the given problem. So for the given example, you can see 1, yeah, 4, 4, 4. 4 is repeated thrice. So only 4 is written only once. That's the root of the subtree. Next is 2 comma 4 and 2 comma 4. In the output they shown 2 comma 4, but you need not to write return 2 comma 4. You just need to return the root of the subtree, that is 2. So this is the example they are given. Now we'll see how to logically solve the problem. So for this given problem as well we saw, I feel DFS is the best method to solve. So this DFS is the best method to solve. How? Let's see that. So I hope you guys know how the DFS works. So for solving this problem, we need a hash map of dictionary. So as you know, dictionary will store the key value pair where key is a string and value will be of integer type. So in this problem, we need this. Why do we need the dictionary? I'll explain that as in when we solve the problem. So we'll be using DFS, right? So we start with the root node. When you start with the root node, so you see the root node once. You check whether it has a left or right node. Yes, it has a left or right child. So you go to the left node again. For left node, you see whether it has a left or right node. It doesn't have right node, but it does has left node. So you go to the left node again. So for 4, does it have a left or right node? Left or right child? No, it doesn't have any child. So you'll return 4. So one more thing is that after 4 there is no node, right? You just represent it as underscore. If there is a node like this, then this will be 4 underscore 1. Then for 1 nothing is there, so just leave it as underscore. Got it? This is for the representation we'll be using, because and this 4 underscore 1 appeared only once. So this will be considered as string, because in the dictionary the key value is the string. It should be a string. So we write it as 4, then underscore. It doesn't have anything of that as a left or right node. As I said, if 4 extends to 1, then it will be 4 underscore 1. Then 1 doesn't have any node, so just write underscore and leave it as it is. So this is one thing. So 4 underscore is appeared once. Key value pair in the hash map. This is where we are using. Next, after 4 is done, 4 doesn't have any left or right node. Now you return the 4. Then you go back again for 2. 2 doesn't have right node. You already traversed the left node. So return this node traversal as well. So it will be 2, after 2 underscore, then 4. 4 doesn't have anything, so underscore and leave as it is. How many times it has appeared? Once. Next, you go back again. 2 is done, both left and right node. Right node it doesn't have, 2 is done. Next, go back to the root node 1. 1 you cannot retrieve now itself, because only the left part has been completed. But the what about right node? Right subtree. It's still left, right? So you need to traverse over the right subtree now. So go to 3. Does it have a left or right node? Yes, it has both. First you go to the left node. 2. 2. Does it have a left or right node? Yes, it has left node but no right node. You go to the left node. 4. Does it have a left or right node? It doesn't have both. So you retrieve 4. So 4 underscore. 4 underscore, right? If you observe, 4 underscore is already here. So this one value will become 2 now. Twice it has been appeared. That means what does it indicate? 4 underscore is appeared twice. It's a duplicate node or duplicate subtree. Since it's a single node, I'm telling it as duplicate node, or it's a duplicate subtree. So in this case, duplicate subtree, as I told, we have to write only the root of the duplicate subtree. Here it contains only one node, so we'll be returning 4. You need not to return 4 comma 4. Only once if you return, that is fine. It's given in the problem itself. You only need to return the root node of one of them. So this is done. After 4 is traversed, go back to. Does it have a left or right node? Doesn't have right node. We traversed left node already. So you can retrieve the 2 part as well. So it is nothing but 2 underscore 4. Then 4 doesn't have anything. So underscore. We observe 2 underscore 4 underscore already present, which we got retrieved here in the right part. So that means even this value will become 2 now. So even this belongs to the duplicate subtree part. When we solve the problem, we could see, 2, 4, 2, 4. It's the same part, so it's a duplicate subtree. And the root node will be here 2. So you need to return 2. So once you're done with 2, go back to 3. All the left node traversal is done. So does it have a right node? Yes, it has a right node. So go to that node. So 4, does it have a left or right node? It doesn't have both. So you retrieve 4. That is nothing but 4 out of that underscore. But 4 underscore already present. Do we need to increment it to 3? You can do it, but it's not necessary, because if the same subtree appears twice, that itself proves that it's a duplicate subtree. You need not to look into for the further appearance of that subtree in the original entire tree. So 4, it may not become 3. You can return it as 2 only. Once you find that 2 subtrees are present, that itself proves that it's a duplicate tree. So 4 is done. Now go back to 3. Both left and right node traversal is done. So retrieve the 3 node subtree, that is what 3 underscore 2. First you traverse the left part, then you traverse the right part. So 3, then underscore 2, next underscore 4. Out of 4 nothing is there, so it means just underscore. Next go this part, here one thing is there, so underscore twice. One after 4, then again here. For the after the left part is done, you go to the right part. Here you have one line, so you give underscore. Next again 4. After 4 nothing is there, so just leave it as underscore. This represent here nothing is present. So this is has been appeared only once. Next, 3 both left and right node part, subtree part is done. Next you go to the root node. Now for root node, the left part is done, right part is done. So now you retrieve the root node traversal. How? First you return 1, after that traverse to the left part, then go to the right subtree. In the right subtree, again traverse to the right part, then go to the left subtree. So 1, but before all the left and right subtree, you have to retrieve the root node. So 1, after that underscore 2, then 2 underscore 4, after 4 nothing, just underscore. Next, right part is done, go to the right part, underscore 3. 3 is the root node here. Here it has left part, so first go to the left part, then right part. So 3 left part is 3, underscore 2 underscore 4, underscore 2 underscore 4. 4 doesn't have anything, so just leave underscore. Here left part is done in this subtree. Go to the right part, underscore again. Then 4. 4 doesn't have anything, so underscore. How many times is it appearing? Only once. So you could see only this part 4, 4 and 2 and 4 has been appeared twice. So this is a duplicate tree. So in this case 4, 4, 4 is the root node. 2, 4, 2, 4, 2 is the root node. So we'll be writing 2 and 4. Now we'll go to the implementation part, how we shall code it. So at first we need to define or declare an empty array list of tree node object type, so that it will store variable number of tree node objects, because the answer returns the root node of the trees. To store that, we need an empty array list. So list of type tree node, we'll give it as res result array. So new array list. After this, as we seen in the problem, we need to have the dictionary of hash map type. So we'll declare a hash map that contains string and integer. String is for the key and integer is for the value. So that is nothing but dictionary equal to new hash map of type. So this is for storing the result, and this hash map is storing for the subtrees which we traverse each time in the DFS. These things. So after this, now we shall declare a function to solve the problem using the DFS. Public string solve contains tree node, that is nothing but the root node. We start with the root node, right? So it contains root node as a input, then go in here. So the very first case, what if the tree is empty? If root node is if is null, then what we should return? We should return null. So if root equal to null, In that case, it should just return empty. So after this, we shall have to create a new variable of string to store in the key part, string val equal to. So at first we give root dot val, so it will fetch the root value, plus you could see after root dot val underscore, right? So for underscore one thing, next again plus, next recursively you give left part and right node part. So sol of root dot left, after that plus again underscore, then again plus, after left part is done, give sol of root dot right. So why are we doing this? DFS works like first we fetch the root value, then the left part, then the right node part. So the same thing is done here, and that is stored in the value string. So which is stored over here, 4, 6, these are the input val values. So once you get the string, we need to check whether how many times this val value has occurred. Is it the first time or second time, anything, right? Then only we'll get to know whether it's a duplicate tree or not. So each time we have to check for dictionary, like dictionary of val plus equals 1. But this is not possible in case of Java. We know usually in other languages we do this, but here in this case, instead of that, what we need to put is dictionary dot put. You have to put the what? Val value. You have to put the val value into the dictionary, and we have to check whether that part is present in the dictionary already or not. So we to check whether it's present in dictionary already or not, we give dictionary dot get. We checking whether it's there or not. Get or default. If it is not present, then we'll go for the default option where in default you will insert val, comma 0. 0 is nothing indicating 0 times it has appeared. So later, if it is present, later you have to increment it by 1. We performed there, no? 1 became 2. First it was 0, 4 was 0, then 4, 1, 4 underscore 1 occurred, so it became 1. Then 4 underscore occurred again here. Once here, that was 1. Again it occurred here, so it became twice. So that is what we are performing here. So we are putting the val value. So for after putting the val value, whether we check it's already present in the dictionary, then you get it. If it's not present after getting also, then you add that value and initialize it to 0, the integer value. Key value will be 0. Later you increment the value by 1. Either if it is present or not present, you have to increment the value by 1, right? Because initially here we initialize it to 0, so it should become 1. So next after this, you have to check if dictionary dot get which value val, if that is equal to twice, if that appeared twice, then what should it do? Result dot add of root. We have to add root to the result list. So this means if it has appeared twice, that means it's a duplicate tree. Then we have to add this to the root node. Add the root to the new array list result to get the answer. So after lot, at last you just return the array list return val. Now, yeah, now we shall return in the main function. Okay, the main function is over here. I have written. This is a mistake which I did. Okay, yeah, now this is fine. Inside class, you will initialize these two, then the new function which you declare here. Now you call the function in the main function. How do you call? Sol of root, and you need to return the result array as the answer. So we shall run and check. Yeah, answer is getting up accepted. We'll submit it. Yeah, the problem has been solved. I hope you guys have understood the problem. Please subscribe to my channel for more such videos. If any doubts are there, put it in the comment section. Thank you.